Hey guys, this is Corcrest here. In this video, we are going to make a homemade digital clock. Basically, making it is very easy if you just take a LCD display, connect it to the Arduino and upload the code to it. But we are not doing that. Instead, we are going to make the LED display ourselves, which will show us the time. Our final project will look like this. These LEDs show us the time. This area here shows the hours. This shows the minutes, and these two central LEDs turn on and off with an interval of 1 second. First, let me explain some beginner stuff, then we'll begin building this whole thing. This thing right here is called Arduino. In it lies a microcontroller chip. This chip will basically do all the processing that we need to make our project work. We actually need the digital pins of the Arduino here. Alright, let's begin now. We'll first place two LEDs at the center of the perforated circuit board. Just next to these, we're gonna place some LEDs the way they look like number 8. Why 8? Because the shape of this number can generate any other number out there of our choice. Alright, we've gotta do this 3 more times. Finally, we'll have something like this. This single number 8 is made of 7 segments and each one of it is made of 3 LEDs. Let's solder the LEDs in place. So because I have these electrical pathways drawn horizontally on my circuit board, I'll solder only the anodes of the LED lights. Why to do so? You'll get to know that later. If you don't have a board like this, then just solder everything like normal. After that, we should cut this extra wire of the anodes that we just soldered. Please don't cut the cathode. Now of course we can just connect all the LEDs to the Arduino, as these are total 86 LEDs and Arduino just has 14 digital pins. But we can do some cheating here. We can connect each of these 3 LEDs parallel and consider every group like this as a single LED. And then connect these whole segments of foam to the Arduino. But still there are total 28 segments, which are again more than the pins present in the Arduino. So what do we do now? Here comes something called multiplexing. Using this, we can reduce the number of pins required to run a LED matrix. Now this thing here can also act as a matrix if we connect these segments with each other this way. Here all the anodes of the LEDs are connected horizontally and all the cathodes are connected vertically. But we still got 17 pins. To reduce the pins even further, we can make some modifications to this. Like, instead of connecting these two segments directly, I shall connect this segment to this one on the top and then this one to the one on the right. And do this with all the others too. Also, I'll move this part here and make new connections like this. Finally, we'll have 6 pins on these sides and 6 at the bottom. And that makes 12 pins emerging from the matrix. So basically by using multiplexing, we reduce the number of pins from 28 to 12. Let's make the connections now. Here we have to connect the anodes of all the LEDs in this area. These pathways have already made some connections, like all the anodes in this and this lines are connected horizontally. We just have to connect these 3 lines together. To do that, I'll use these small wires. Let's just solder these wires now. These LEDs are already connected with each other, so no need to bother about them. Now for the cathodes, we have to connect these and these cathodes together. These cathodes here can be connected with each other using the electrical pathway beneath. So let's solder these to the board. Also, it will make it more easier if we bring these cathodes together and solder them. Do this with all the others too. Now here we have one problem. We have to keep this group isolated from this one, but these pathways are doing just the opposite. So we gotta cut the pathways. I'll use a cutter for that. These are actually not hard to cut. Also, some of these pathways are establishing the connection between these cathodes, which we absolutely don't want. Let's cut them too. Now we just take a copper wire and solder its one end to the cathodes of these LEDs and other end to the cathodes of these ones. For these two center LEDs, we'll just bring the anodes and cathodes of both the LEDs close to each other carefully, solder them, and then just connect the wires. So for connecting the LEDs to the Arduino, I'll basically follow this schematic which I made. The download link to all the schematics used in this video can be found in the description below. Before we connect these wires to the Arduino, we have to take care about how much voltage and current we need to draw from these LEDs. The Arduino supplies 5 volts in any digital pin, but the LEDs require only 2 volts and 20 milliamperes. More than that, the LEDs might get damaged. We need some resistors to prevent that from happening. We can easily calculate the values of the resistors we require by using the Ohm's law. We need 2 volts for the LEDs, that leaves 3 volts for the resistor. Now a single LED needs 20 milliamps of current. These groups here that have 18 LEDs will require 360 milliamps. The value of the resistor comes 8.33 ohms approx. For these groups, the value of the resistor is 25 ohms. So for connecting the LEDs to the Arduino, I'll basically follow this schematic. The download link to all the schematics used in this video can be found in the description below. You can actually connect these LEDs randomly to any digital pins of your choice, but that might make the code a little bit confusing. Now we connect the Arduino to our computer using a data cable. Then open a browser and go to Arduino's official site arduino.cc. Click on Software. Select your operating system. I already have it downloaded, so I'll just cancel it. After the download finishes, we'll get the setup. Let's install it. After the installation finishes, we'll go to the link given in the description of this video to download the code containing file. Open it. Select your board. I'm using Arduino Nano. Select your microcontroller and then the COM port with which we connected Arduino to our computer. Then we'll simply upload the code using this button. Now let's go through the code real quick. The code is rather simple. I haven't used any libraries in this code. It's just simple Arduino code that uses the crystal oscillator in the Arduino to tell the time. These values here can be changed to set the time. These are hours, minutes, and seconds. This much code here takes care of the time. And the rest of this displays the numbers generated by this code on the matrix. Now as the time here is generated by the crystal oscillator of the Arduino, the time may show some errors after a couple of hours of usage. Therefore in the next video, we'll add a RCC module to our project to eliminate any chance of errors. Also, we'll add a buzzer and make an alarm clock out of this. And maybe use some potentiometers, as we won't be having any digital pins left to set the time without any use of the code. Alright, that's it for this video guys. You have your working digital clock. If you have any doubts, comment section's there for you. And yes, please consider subscribing to this channel.